end, guys, it looks like this.
Send out an email.
This is true.
I'll send you out
And finally, I'll put the marker here. Let's try green, and it looks like this. Let's make sure I have all this copied down correctly. I think it is. We'll try this, close this down, and move into something different. Much easier, in fact. So guys, on the grid here, we'll do these three pieces. Look like this. Okay, the black one. Can anyone tell me, just based on your experience, what should the black one graph into a piece of? A piece of a circle? A piece of a parabola? What should, just the way it looks, the black piece, a piece of what?
Linear.
Linear, it's linear, mx plus b form, so it should be a piece of a straight line. Now this way I do it, it's up to you, I would form on the side here, I think this sort of helps, a little table, and start plotting points. I am going to start out with -2 since they gave -2 to me. And also I'm trying anything less than -2, like -3. And I think only 2 points would be enough. Now the -2 they gave to me, if I take it back to my function, replace it into 4x plus 8, I think you end up with a 0. That's my first point. If I take a -3 back, 4 times a -3, and -12 plus 8 gives me a -4. Now let's go to the grid and plot those two and see what happens. Let's make sure all those points are correct there. I did it quickly. Okay, out -2, 0. Now when I get out to -2, 0, right here, I'm going to start here. Should I, based on the way it's explained to me or given to me, should I include -2, in other words, darken it in to show it's included, or should it be open? Open. So that is something I'd watch out for on the exam. There's no equals mark here. Just open. But I got -2, 0. Now I got -3 down 4. So that's here. Just be patient. Mark -4 here, guys. That's down here. I lined these up correctly. And I think lined up, see if you guys will agree, is going to look something like this for a piece of that straight line. Is that the first piece done? I hope. Second piece. Yeah, what?
For the -3, -4, would that be an open circle?
Everything after the beginning is included.
Okay.
It's just that beginning point you got to watch out for, whether it should open or close the beginning. Good question though. The red, as here goes. I'm going to do a table again, based on what they gave me. So we'll start out with a -2, and a little space here, and we end up with 2. They gave those numbers to me. They're also telling me I'm trying anything in between. Let's try 0. Okay, let's take -2 back to my function in red. It says x squared subtract 4, replace x by -2, do your business there. You're going to end up with a 0. Take 0 back to x squared subtract 4, do your computation there. You're going to end up with a -4. Put a 2 in there, 2 squared subtract 4, 0. So at least I have some points to work with for the red one. And then we'll start plotting those points. Okay, Katie, here we go. First point says -2, 0. Based on the red, the restriction, may I now darken in, because I see negative 2, 0 was left over from the black. Can I now go ahead and darken that in for the red? The other points after that are always darkened in. So 0 down 4, guys, is here, included, and then out to 0 is also included. Now, if I connect those, and I think we sort of got a hint here for an x squared should be a what piece of a what parabola. So we end up with something that looks like this.
How is 2, 0 included?
What's that?
How is 2, 0 included? Does X's?
Oh, right here.
No, for clock, like 2, 0.
Oh, hang on. I see what you're looking at. You're looking at the end. Now, at the very end where it says 2, was there an equals mark on that inequality right here? At 2, there was here. I included this one. Was there an equals mark here? Katie? No? Samantha? So you're saying, Professor, I'm going to do it shortly here. That should be open. Is that true, guys? Not to be included. Now, the green one is a square root graph. We know what a square root graph looks like. This one starts at 2. If you want to plot a few points, go for it. Guys, we'll do this in green. I'll try to keep all this together. 2 here. And they're telling me I'm trying anything bigger than 2. My goodness, let's try 4. It's up to you. Replace the 2 in the green. I end up with square root 0, which is 0. There's a nice point to work with. Put a 4 in there, that's square root 2, not bad. And there's your second one. You can try other points if you wish. Now, you can plot those and go from there. Now, 2, 0. Oh my goodness, I'm back to here from the red. Can I now darken this in from the green, the way it's presented to me, or not? Is there an equals mark here?
No.
No, so I got to leave it open. The other point is out 4, up radical 2. So guys, if I move out 4, up radical 2, and I think most of my students realize what radical 2 might be close to, is at 1 point something, square root 2. So it's out 4, up radical 2, and we'll try to do this in green. Let's do this, out 4, up in here somewhere maybe, there. And please tell me it's going to look something like that or not.
No,
Or is it going to look something like that?
like that.
Yeah, let's go ahead and do that. Then we step to the side there and make sure all that's correct now. Does that look good? Woo! Yes?
Why is it including? Why is the point for radical 2 included?
Oh, beautiful. Katie was asking about this. Anything after the initial, you see the initials that they give you, those initial points?
Mm-hmm.
That's where you got to pay attention to whether to include or not include. Anything after that is always included.
Okay.
It's just those initial points that you got to worry about. Make sense, guys? So there's the graph of a piecewise defined function, and you're done. Except, when someone closes this down, expect good exam result, let's ask you to find something like this. I'll just make up something real quickly. If I ask you to do something like that. On that piecewise defined function. Guys, first says g of 1/2. We had a discussion last week. That does not mean you go through here and replace all these x's by 1/2. You're going to find where 1/2 fits. So guys, is 1/2 less than -2? Is it the first piece I should use? No. Is 1/2 caught between -2 and a +2?
Yeah.
Yes, so I should be using the second piece, the red, to find the value. So in the red there, it says if you want to calculate this, go to the red, it's 1/2 squared. Subtract 4, I'm gonna block that off so I will not forget it from the red. Next one says 2 times, oh, this is gonna be an interesting test. G of a -6. -6, where is -6? Is -6 less than -2?
Yeah.
So I should be using the first piece only. Replace there, 4 times a -6 in the first piece. Plus, I think it's 8. Got that. Beautiful. Then subtract G of 18. Where does 18 fit? It fits in the green one. 18 is bigger than 2, so use the green one. I think it's 18 subtract 2 gives you what, square root 16? And then do the calculation. I think everything's been put in correctly. Is that true, guys? On top of the board here. So I got 1/4, subtract 4. This is all math. This is where we all make mistakes. 2 times inside there is -24 plus 8. Is that -16? And then on the end, of course, is 4. Yes, no? To do more, let's go back out front for the math here. Guys, 1/4 subtract 4, you could use a common denominator of 4, put those together, or you could merely call it -3 and what? 3/4? Okay, it's up to you. -3 and 3/4. In the middle here, twice that's a -32. And of course, you got to subtract 4. Now I'm gonna leave that up to you guys. You can put all those numbers together. I think I've done all that calculation I need and get a final answer. Is that true? I see some looks like I'm still on break, Professor. I don't know. Are we okay on that? Now, thank goodness. These preliminaries are basically over. I can finally start the course. You say, Professor, the course hasn't started yet? No. It hasn't started yet. We've covered basically what they would expect you to have for pre-skills to walk into a class like this. So we took a little time to do it, but I think it was helpful to go through these skills before I really jump into it. The course really hasn't started yet. Aiden saying, oh, Professor, my goodness, I thought the course had started day 1. Whoa, there's just some little pre-skills to do. We haven't started the course yet. Guys, any concerns here? We're closing down that. Now, let me check. Let's see if I'm ready for you. You have on the back of your review for the test something we're going to look at. Now, guys, when I jump into this, I want to see a few smiles, because I think if I were a student, after seeing what we've done today, and Mr. Park did with the transformation problems, and we did in class, and the discussion's always good in this class. I love this class. But when I do this, you're going to start smiling. You're saying, Professor, that's chapter 2? It's a relief. Wait till you see what's going to happen in chapter 2. So we're going to start here. And by the way, we start with section 2.3, okay? Now, could I have a student who has this read a little bit for me first, and I'll try some of these exercises. It says methods of solving, and it says quadratic functions. Can someone read a little for us here? On the top there of this handout. Go for it.
Methods of solving factoring, quadratic, completion squared.
Now, that put a smile on my face now. I think we did this the first day I met you guys. I think I was talking about completion of the square, quadratic formula, and factoring the very first day I met you. You remember that first day you had smiles on your faces? Yeah. Now you say, wait, Professor, we're going back? We're going back. Now, when I say go back, and since I'm limited on time here we go. Part 1, I did on the handout to start section 2.3. It says find the real zeros, in other words, solve. And I'm going to do this, guys. I'm going to try not number 1, which says complete the square. We all know how to do that. I'm gonna jump into number 2. And it looks like this. Now, bear with me. X to the 4th plus 4x squared subtract 32. We're gonna solve that. Now, can someone tell me, and I notice on the side there I said let u be something. We don't know what that means yet. But can someone tell me what's the issue with what was just read to me, where it says solving quadratics, and we do it by completion of the square, we factor, we use quadratic formula. What's wrong with that example? What's wrong with, why would I have it on the handout? Can someone tell me the issue first, then we're gonna try to show you how to take care of that issue. What's the issue on this problem? Go for it.
It's not the quadratic formula.
It's not a quadratic. What identifies a quadratic for you? The highest exponent should be a 2. Then you get 2 answers. This thing's telling me I'm supposed to get how many answers? 4. We haven't done one of these. I'm looking at it, and some of my students in class may recognize what's going to have to be done. I think it might, even though it's not a quadratic, it might. I see some students say, Professor, I think it'll still factor. I'll be clever, Professor. I can make it factor for me right now in the form you see. Before I jump directly into it and factor it, let me show you what that let u be. On the side here. On the handout. I want you to first, before I jump into it, some students can factor in the raw form you see right now. But let's make it look like a quadratic. We're accustomed to quadratics. You say, Professor, what are you going to do? I'm going to change this and make it look like a quadratic. Not a degree 4. I'm going to see a degree 2. You say, how am I going to do that? I got to choose something here for u and make a substitution. It's called u substitution. And rewrite this, and it may turn into now a quadratic rather than what they call a quartic, where the highest exponent's a 4. Guys, does anyone have an idea, and some students may, what might you let u be, then I'll go back and rewrite it with u, and it turns into a quadratic? Go for it.
So I'd say u should be x squared.
Hang on now. So you're telling me, Professor, and we'll see why you chose that squared. Go back, and everywhere you see an x squared in this, put a u. Well, I can do that. That's just substitution. If I do it, guys, it now looks like this. This becomes, I know and you know, x to the 4th to begin with is the same as that. That's x squared squared. That's x to the 4th. He says if you see an x squared, Professor, put a u. I will. This now becomes u squared. That's a quadratic. Then over here it says now plus 4 times, oh, there's another x squared in the second term. He says everywhere you see an x squared, Professor, put a u. And I'll bring it down here to line this up. And then of course on the end I have subtract 32. No x to worry about, no u. And now look at this. We'll block this off. That is a quadratic. He's changed this into a quadratic for me. Now let's apply one of those techniques. Now I think the fastest way with the time I have here, I think this one will factor. And if it does factor in that quadratic form, here we go. U. Guys, help me out here for 32 to get a 4. Is it plus 8? Minus 4? Yes or no?
Yes.
Split this up. And by the way, you're supposed to set this equal to 0. Try to find the zeros. They call them zeros. This one looks like this. We know how to do this. This factor looks like this, which implies I have u to be a -8 and u to be a 4. No problem. What was the original function expressed in terms of though? X. They want to know what is x. All I need to do is u is equal to a -8. I'll put it beside you so you guys can see it. This is the same as saying x squared is equal to a -8. U is equal to 4. X squared is equal to 4. Now I have this back in terms of x. Now, do we still have an issue? even at this point. And by the way, in my directions, did I say find the real zeros? Oh, if you attempted to go further here, I'm assuming you're gonna take a square root. There is no square root of -8 in the real number system, so this is out. If I do a square root here, and I ain't gonna put plus minus, it should be two answers. You know what this is. It's gonna be plus minus 2. He said, Professor, after all that work, are you telling me, back up here, the solution, more than one, to the original problem are these two numbers? That's exactly what I'm saying. And those are the real zeros. Done. Now, I think this was fairly easy to follow here. I turned it into a quadratic. Now, before I take questions, I'm sure, I've got a big class here. Can anyone tell me, could I have factored, sometimes you can, could I have factored in the original form they gave me, x to the 4th plus 4x squared business, and got the same answer? Could I have factored it to begin with and not turn it into a quadratic on this particular problem? Sometimes you can, sometimes you can't. Does anyone have an idea what this would look like factored at the initial for an alternative?
Use the synthetic division.
To begin.
Using the synthetic.
No. I just want factoring. What would the original look like factored if you had jumped into it and factored it and not done what I did, all this business about quadratic? I think in this case, the original would have factored. Sophia,
Would we have taken out the x squared?
tell me more.
Would we have taken out the x squared?
Not the x squared. You're overlooking something. The original, in this case,
What about grouping?
that would fact, no grouping needed. You're overlooking it. The original would have factored. Look at this. Are you kidding? Please tell me, is the original black equivalent to the blue in factored form? Without me going through this. And in fact, x squared plus 8, leave that alone. But the x squared subtract 4 difference of squares could have gone down further into that. This part right here. This is from Algebra 1. I think you teach Algebra 1 in 4th grade now. And my answer, split this up, you're going to get a 2 and a -2. Which we eventually did here. Okay, sometimes that happens, and sometimes not. So I prefer to make it look like a quadratic, deal with it as a quadratic, and go from there. Now, the next one I want to look at with you. Looks like this. Beautiful. It's number 3, it's h of x. Put it up here. And it's given to me as this. This is interesting. No graphing required here. 3x subtract 13 square root x subtract 10. Step back, make sure everything's copied down correctly. And they ask you to solve that equation. Find the real zeros. Okay, I'm doing a little erasing up here. Can someone in this class tell me what if you were just approached and said, solve this equation? What might, before I show you what I'm doing to it myself, what might you think of that we have done in this class to get a start? I saw some hands going up. What might you try? Yes?
So find the u.
Okay, now, he wants to go back to let u be something. This one's going to really show you how that is really beneficial. But tell me what you might, suppose you knew nothing about u that I'm discussing right now. What might you do in an attempt to solve that thing that we've done in this class? And in fact, I think you've probably done it on either a quiz or the first exam. what is coming to mind that maybe we would do? Yes?
Maybe we can take the 13 square root x to the
They get that square root part by itself, right? Get it on one side by itself. We've done that in class here. And then do what to both sides? Square both sides. That's all we would not be able to do right now. But I'm gonna show you another technique. It's gonna be much, 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 much faster. And we're gonna make it a quadratic. By the way, guys, that thing looks nothing like a quadratic. I don't see an x squared. Now, if, through his suggestion, he said, Professor, we're asking you to do this. He says, isolate the square root part by itself. I could. Let me move it to the other side. Leave this where it is. And then I think next would be what? Square both sides to eliminate the square root. Square both sides. Oh my goodness. I will do it. I think 13 squared is 169. So it's a 169x. On the other side by FOIL, you guys call it FOIL, is 9x squared. Subtract 60x plus 100. I have to show you this. That's the old way. That's what we would do in class. Now, by the way, is that now a quadratic? Is the highest exponent 2? Is it now a quadratic? It's not in good form. So guys, I need to move this over. 0 is equal to 9x squared, quadratic. By the way, if I move that 169 over, I'm getting crazy numbers. 60 and 169, help me out, is how much? Add them up. 229? I'll do that real quickly. Is it 229? I think. Minus? Plus 100. Oh my Lord. They do not pay me enough. No way. For another professor, I don't think, show you all this. Now, I don't want to use the quadratic formula on that mess. You know the quadratic formula, negative b plus minus business? I don't want to use those big numbers. Does anyone think it factors? If it factors, I'd love for it to factor. Oh boy. And I'm trying to avoid the quadratic formula.
I think we need to multiply 9 by 100.
Hang on. So you're maybe telling me right now, maybe 9x and x? Okay. Now what? I gotta get 229 in the middle. I gotta have factors 100. And who knows, we may stand here until my time runs out tonight, and it may not factor. I'm hoping it would. Then I'm gonna show you the shortcut. Guys, 9x, x, it could be 3x and 3x. If someone thinks they have it, please let me know. Will this thing factor? That'd be a nice little challenge problem. I don't know. Myself. I need some help. Mr. Park? Is that thing going to factor?
I think so. 25 and 4.
25 and 4?
Mhm.
Okay, hang on now. You said maybe put 25 here and 4, or 24 here and 25 here? Hang on. Right? You gave me 25 and 4, right? Are you using AI?
No.
Now, let me check right quickly. That product, guys, 9 times 25, help me out, 9 times 25 is, what's 225? Negative. Inside there, these two, that's a negative 4x. Put those together. Is that negative 229x, which I wanted? It does factor. I see Aiden with that smile on his face. He says, Professor, I'm enjoying this class so much. I just love this class. Also, those numbers are like magic. They just fall out. Now, since I have factors, you say, Professor, now this is an old type problem. We've done these before. Let's split this up. And solve each one. I'll do it quickly. We'll end up with 4/9 and a 25. I said, what? What's the original problem? What's up there? Jeez. 4/9, 25. Does this have a square root? Did I not advise you when you saw a square root on the exam or the quiz, you should check it? Remember, sometimes they don't work. But right now, we think those two will work. Now, I haven't checked anything yet. Now, you said, Professor, are you telling me there's a shortcut here? You're telling me, Professor, that's the reason you placed this on that handout? There's an alternative to find those answers? Here we go. Now, let's go back to the original. Look how crazy this looks. Now, on the side there in your handout, I have to let you be something. So when I go back and replace you here, it turns into immediately a nice little quadratic. Yes.
Let U be radical X.
Thank you. Hang on. Hang on. Hang on. Now let's see why she chose radical X. My first term, 3x, could be expressed as, if I wish, and I wish, it can be expressed like that. That says 3x. Then, of course, the middle term that she's telling me has the radical x. And, of course, I subtract 10, like that. And she says, please, Professor, everywhere you see a radical x, put a u. So this becomes 3u squared minus 13u, subtract 10, is equal to 0. Now, before we get too excited, please tell me, is this looking much more doable than that? And eventually we're supposed to get the same answers. I've taken this thing down to a form now which looks much more doable over here. To do it, if it can, I think factors. Much easier though. 3u, u, looks like maybe a minus 5, let's see if it is, and a plus 2. Let me step back and look at it. It is. Split this up. We're going to end up with u to be equal to a negative 2/3. Guys, I'm going to solve them quickly. And u to be equal to a 5. Now, what was the original in terms of? It's x, and asking me to solve for x. So the u here was representing square root x, so that's radical x equals negative 2/3, and a radical x is equal to 5. Now, how would you finish up from there to see what x is? What are you going to do next? We're almost got this thing finished up. What are you going to do next to get x? Square both sides of each one. This one's easy seen. If I square both sides here, you're going to quickly end up with x is equal to what? 25. Now, I think 25 was one of the answers from this long approach we took. What are you going to do to get the answer here? What are you going to do here? Yes?
Control u equals, oh, that's 2/3. Sorry, I couldn't see that's a negative.
That's a negative 2/3 here. So what are you going to do to get the answer on the first part? I went ahead and did the second part, got 25. What are you going to do to get the answer on the first? Go ahead and say it.
Square both sides.
You know you're not. That's what I was hoping to hear. If I were a student, I'd say the same thing. Professor, what's wrong with you? Square both sides. You square both sides here. What's wrong with, and if I were a student, I would say the same thing. You square there, you'd end up with x equals 4/9. And that would agree with what? what we got back there on the long approach. Is that true, guys? Why can I not do that there? Tell me why I could not, I did it here, I got 25. I could square both sides. Why is it not permissible to square both sides on the first one to begin with? I see hands going up. Sophia, what's negative? Would a square root ever be equal to a negative to begin with? So as I saw that, you'd have to do this immediately. You have only one answer, 25. Hold on. How many answers did we get the other way? We got 2. Did we get 25? So the 25, I got the second with the let u be something, we got 25, and then we got 25 from that long approach we took. But it looks like I got, what, 4/9? But the 4/9 was ruled out, so there's something going on. So why can I not accept 4/9 over here? We quickly saw it here, it's ruled out. Can someone tell me why might 4/9 be ruled out in the other approach? And finally, we both end up with 25 only. Yes?
Maybe you could plug 4 9s into the original problem and see if it equals 0.
Thank you, mathematician. I'm gonna take 4/9. I'm gonna check it in the original. 3 times 4/9. Subtract 13, square root 4/9. Subtract 10. Make sure I put that 4/9 in correctly up there at the top. Guys, this is 12/9. Square root 4/9, at least it's perfect for a square root. It's what, 2/3? And then 3 out front, 13 out front. I got 13, we'll put that in first, that's 2/3. Subtract 10. So guys, I got 12/9. Oh my goodness. This is 26 over 3. Subtract 10. I'm just doing some math there and watch me mess up myself. Okay, 12 over 9 minus 26 over 3, subtract 10. And what would you do as a good student now to finish up? Put all this together with a common denominator, is that true? Of 9. Which means you've got to multiply this one by 3. This one should be over 1, multiply this by 9 by 9. What a common denominator. If I had no mistake, I got 12 on top here, subtract, what is 26 times 3? 78. And we've got to subtract 90 down there, if there's no mistake. What is all that supposed to have given me if it checked? Where is it? If I check it, put it back in, what should I get down here if it did check? Which looks like it's not going to check.
0.
0.
It does not equal 0.
It's not equal to 0. Therefore, 4/9 has to be ruled out even in this old technique. It's not going to check. Got some strange numbers here. I don't think those will give you a 0 down there for a check. Here, I think it's much easier. You still have to rule it out to let u be something. Wow. Now, let's see how much time I have here. Beautiful. Let's check here. Okay, one more. Number 4 on your handout says this. N of x, I think it was. It is n of x. N of x is equal to, and I want you guys to do something for me here. This is x to the 6 plus 7x cubed, subtract 8. Now, I must tell you, I was debating big time to myself, should I place this on the handout? N of x. Another notation, f of x, n of x, notation. Now, let's first discuss what you see. if I saw this as a student, it'd be scary. How many answers are implied that we should get? How many answers does that say, don't leave this room until you get, how many answers? 6. 6. You walk in here and I have an X to the 20th? You're supposed to get 20 answers. Thank goodness it says just 6. You were supposed to get just 6 answers. Now, can anyone, and I'm gonna try to let you be, did I say let you be something on this one also? So let's try to turn it into a quadratic, even though some students probably could jump into in the raw form you see right now. Can anyone tell me, I'll take questions here, what might be appropriate to let you be, and to give you a hint, this first term could be expressed as that. That's x to the 6th, not x to the 5th. That's x to the 6th from across the street, that middle school. Now, what might you let you represent, and it's going to turn into a nice little quadratic for us? X to the 3rd, x cubed. Guys, if I do, this becomes u squared plus 7u minus 8 set equal to 0. Everyone in class would agree. Here's the original. I have it down here. Is this much, much better? This is a quadratic. This takes us back to old stuff. Now I'm going to try to factor this. Quadratic formula completes a square. For the sake of time, I'll think of factors. And if I do factor it, what a class tonight, this is nice. I think it factors into u plus 8, u subtract 1. Little factory. Set these equal to 0. You get negative 8 to consider. You get 1. What was the original function in terms of? Was it in terms of u? No, the original was in terms of x. We're saying solve for x, so I'm not quite finished. What was u representing? We decided u should represent x cubed, so this becomes x cubed is equal to a negative 8, and x cubed is equal to 1.
So do we need to take the cubic?
Hang on, I know what you're gonna say, hang on. Can anyone tell me at this point, right now in the blue, we're looking for 6 answers. Can anyone tell me x cubed is equal to 8? And don't let me see you out on campus somewhere, and you come up to me and say, Professor, how you doing? I may not say much, I'll just say x cubed is equal to 8. That's how I'm doing. What's x? Have a good day. What is x in this case? X cubed equal to 8, negative 8, I'm sorry. X must be equal to automatically? Negative 2. Negative 2 times negative 2 times negative 2 is negative 8. The other one is more obvious here. If x cubed is equal to 1, what's x?
1.
1. I have right now as answers negative 2, 1 for the x. Not you. I went back to the x. That's what they had this thing written in terms of x. How many answers were we supposed to get? How many answers to get? Should we get 6? Wait, hold on. How many are missing? 4.
Could be.
Hang on, don't get too excited yet. There are 4 missing. I should throw this out as an offer. That any student in this class that could tell me within the next 5 minutes the other 4 answers, you're done. You're done. I'll report an A for your transcript grade. Enjoy. I want the next 4 answers. Supposed to get 6 answers. There's 4 missing. Here we go. Go for it.
They're not real.
Some may not be real, unreal. Maybe a little I coming in, imaginary, which we haven't discussed yet. Tell me more.
Wait, 0, where is 0?
Hang on, so if you say 0 is one of the answers, I'm checking right quickly. Let me go back and replace all these X's by 0. I better get 0.
Wait,
0, 0, I'll get -8. We'll check.
No, I take that back. They're just not real.
But if I thought, heard that offer, what? You're finished? Transcript rate's gonna be an A, stay home, do whatever you want to, goodbye. I need 4 answers.
They're repeated?
What's that?
Are they repeated?
Oh, good question. No. Now, good question. You said, Professor, maybe they repeat. And sometimes they do. They, very good, but in this case, they will not. See? Mr. Park, we're not gonna lose any students. No one's gonna take the offer. I need the other 4 answers. And I see one student over there working away. Whoops, whoops. Okay. Now, I'm looking at my time here. I don't have just enough time. I want you guys to do something real quickly for me tonight, before the exam takes place on Wednesday. With my little bit of time here, darn, these classes are way too short. I think I'll try to get through maybe 2 more of the answers. So we'll have 4. And then we got 2 more after that to find, which I may not have time tonight to do. Yes?
2.
Oh, you think 2 will work?
No, it's the,
Do it again.
yes.
Okay, I'm gonna try to get 2 more answers now. And we're supposed to get, what, 6 altogether? So there'll be 2 more missing. Here goes. Oh, boy. Oh, we factored this thing, didn't we? Hang on. That's cute. Hang on. Here's the hint. My way to feel good about this came from that diagnostic test that they're giving at UC San Diego. That's where I took this. Here we go. U plus 8. Let's go back to this. What was U representing? What did I say, let U be? Or you guys told me let U be what? X cubed. So this right here could be written as X cubed plus 8. And the other one, I've got U minus 1, where U again was representing what, X cubed? So this could be X cubed minus 1 equal to 0. Now, with the limited time I have, we have 2 of the answers. We're missing 4. Does anyone recognize now, since I've rewritten it like that, X cubed plus 8, what might, it's been a long time for some students to have seen this, I guess. Does anyone recognize at all, not X squared minus 4, not X squared subtract 9, X cubed plus 8? There's something going on.
Sum of cubes.
Sum of cubes. Are you kidding? He said, Professor, geez, I don't know what a cube is. What's she talking about? She said, Professor, there's something that looks like this. A cubed plus B cubed. Now, I don't know, she may know. Does anyone think they remember what A cubed plus B cubed factors into? And one of my students tried this with ChatGPT as an AI, and they gave the wrong response. They gave the wrong response.
Is it A plus B?
Oh, hang on. A plus B, I'll start with A plus B. 8, here goes. A plus B for sure. Now, the next part that you gotta be careful with. It's like a rule to follow. But it's been a long time since you more than likely have seen it, but I need it. Oops, I see hands going up.
Is it a squared
Hang on.
I wanna say minus AB plus B squared.
Mr. Park, when are you leaving me as an assistant? When are you leaving me?
Next summer.
You'll be with you for the summer. Then I'll be looking for a new assistant. I'll be looking for a new
with you
assistant.
next summer.
I have a question.
Guys, does anyone recognize that?
Yes.
There's your formula. That will factor. Now, I'm looking at my time here. If I apply her formula, this is the formula to factor the sum of two cubes. Guys, I'm trying to factor x cubed plus 8. You gotta keep in mind now, this is the same as 2 cubed. That's 8. Yes.
Yeah, I have a question. What about not adding to, for example, why not a squared minus 2ab?
Ah, beautiful, I know what you're thinking. You're thinking about a plus b squared.
Yeah.
First, sort of use that method, they call it FOIL. Or if you expand it out, a plus b squared, you'll get a 2ab. Not for the cubes.
Oh, it's not for the cubes?
No,
Okay,
no.
thank you.
I know what you want. You want me to stick a 2 right there. Now, I don't have the time tonight, but with that beautiful help, I guarantee you, if I stood here and multiplied this out, it's messy. If I should multiply this out and check her answer, it should take me right back to a cubed plus b cubed. I'm hoping. Now, let's apply it. Let's use it. Guys, this right here now looks like a plus b would be written as x plus, look at this, 2. Next part that she gave me so nicely there, a squared becomes x squared. Now subtract in the middle, she gave me the product, a times b. What would a times b look like? 2x. Just multiply x times 2. And then on the end says square the b, and the b was represented what, by 2? So 2 squared is a 4. Now, 8. If I had time and multiply this mess out, in fact I should, but if you have time to multiply this mess out, it should take you right back to this. With the help of that formula she gave me. Gee. Now, let's split this up and try to find some answers. I'm gonna split, oh, by the way, guys, it's so tempting to say x squared minus 2x plus 4. Professor, will that factor further? Can I factor the x squared minus 2x plus 4, the quadratic part? Might that factor further? You can try it, but to save you a little time, it won't. And we're not gonna try to factor it any further. Split this up. Set this equal to 0, and you end up with -2. You say, wait, Professor, I thought we had -2 earlier. We did, it's just repeated, -2. Here, this will not factor. This is where I'm gonna sort of stop here, guys, shortly. Can anyone tell me, that's a nice little quadratic. What could you do with that? It doesn't factor. What could you do with it in an attempt to go further? Quadratic formula. Here's the quadratic formula, here we go. X is equal to, I'm going quickly, guys, we're going to end up with a positive 2 out front, plus minus square root. I see a 4 coming in for b squared, subtract 4 times 1 times 4. Oh my goodness, I did that quickly, over 2. X is equal to 2 plus minus, let me step back to make sure everything looks good right now. It does. I think underneath that square root, you're going to end up with 4 subtract 16, which I think is a -12 over 2. Oh. What happened? Can I at this point deal with it? Have we discussed imaginary numbers at this point? Is square root -12 right now to us at this point undefined? So I went through all that work to say, Professor, are you kidding? By the way, how many answers would you expect when we finally get into imaginary numbers? Will this give me 2 more answers when I finally get to finish it up? So I have 2 more of the 6. Where's the other 2? This would give me imaginaries. It will give me 2 with eyes in them.
But now
Later
you-
on, that would go here. But there's 2 others missing. Aiden, what'd you say there?
What did you do the difference of squares, difference of cubes formula below?
Where?
For the x cubed minus 1?
Nice. Nice. Okay, hang on now. So we got x cubed plus 8. Where are we right here? Trying to follow where we are. We got that one out of the way. I got x cubed minus 1, right? Now, guys, if I deal with this one, if I move the 1 over, I got x cubed equal to 1, solve this, and the answer is 1. Well, we got that earlier also. I'm talking about different answers. Difference of cubes. Let me try to find, hang on. Now this is a difference of cubes this time. So I need a formula for, look at this, for a cubed minus b cubed. Not plus this time. Now, look at the first formula, now look at this one. They're very close.
It becomes positive.
Sorry, come again.
It's a squared plus ab plus b.
You got it, so it's a minus b. A, come again. A squared,
Plus ab
beautiful,
plus b squared.
love it. There's your formula. For a difference of cubes. Oh boy, I want you guys to say, gotta do it. 8, with your help here, let's see what this x cubed minus 1 now looks like factored using this formula. A minus b would be x minus 1. A squared, x squared. Plus ab, 1 times x, I think it is, plus b squared plus 1, I did that quickly. You guys, would you agree, is that the way it looks with the help of this formula? For the cubes. I did it real quickly. You guys agree? With the help. I think, I'm not gonna finish it up. I'm looking at it right now. If you set this part right here, which is a quadratic, with 8's help, equal to 0 and solve it, I think in my mind right now using quadratic formula, I think you'll end up with imaginary again. So the last 2 will be imaginaries. The other 2 would have eyes in them. And we haven't discussed imaginaries yet. So if I say find the real zeros, you would say, Professor, if you say use the word real, you would say, Professor, you were done back here. Those are the only reals. The other 4 are imaginary. Wow, what a class tonight. Yes?
Will this be an example?
No. That's what Aiden emailed me or asked me, he says, Professor, I love students. He said, Professor, you had on one side the review for the test, and on the other side, see that 2.3, 2 point whatever? No, that's not on the test.